Okay, so we'll be continuing on vector addition, but this time we will be using the analytic method instead of the graphical method. But in order to make things more um, exciting for the discussion, I'll be countering all the computations in the analytic method with the graphical method. Okay, so let's start with the concept discussion first on of analytic method. Just as what we have presented before, the analytic method is a different set of technique as opposed to ordinary addition or subtraction or multiplication. The analytic method is basically uh, y- uses basically the idea of resolution of vectors, meaning the methods of components. Okay, so to add vectors, you have to resolve the vectors or the given vectors into the corresponding components. And the solution is to resolve a vector into its components. We make use of either sine or cosine, depending on whether the um, components being solved is either an opposite side or an adjacent side. Note that the signs of the corresponding sums of components lead to the quadrant where the resultant vector lies. Okay, so subtraction is simply vector addition with negative vectors. Okay, so we make use again of the Pythagorean theorem in order to compute for the magnitude of the resultant vector. We make use of the inverse tangent theta in order to compute for the direction of the resultant vector. And finally we indicate the resultant vector according to the pattern of vectors of writing the vector with magnitude and with its corresponding direction plus the compass direction. Okay, so let's try to do the example problems that we have presented before. Let's take problem number 1 again, which and this time we will be countering the solution for with the analytic method with the graphical method. Okay, so let's refresh this first. Let's start with problem number 1. Okay, so just like what we have presented before, in the given problem, you are given the two vectors. Both of them are directed east. So the corresponding components, when you compute for the uh, x component, you make use of cosine, and we compute for the y component using sine. For the condition that the angle is measured from x. Let's try to go back to the description of these vectors here in this module. Now, take note of the description of these two vectors. Each of these two vectors are drawn uh, towards the east direction on the positive x, and take note that the measurement of the angle is measured from x. So therefore, when you do the computation of the components, let's draw first this using okay, so as you can see, in the representation of the vectors graphically, both of them are measured from the east direction. So, and based on the description of each of these two vectors, the angle measured here, the 0-degree angle, is measured from x. Therefore, when we do the solution to right triangles, we employ the solution for cosine to compute for the x component, and we employ the solution for sine to compute for the y component. Now take note, it is not always that x is associated with cosine and y is associated with sine. This is not always the case. Uh, what we need to learn here is to determine which trigonometric function should be employed, whether to compute for x or to compute for y. It is not always that cosine is the one that we'll be using to compute for x. Sometimes we employ sine to compute for the component along the x, especially when the angle it was measured from y instead of x. So when the angle is measured from y, what happens to the computation for cosine and sine is that they reverse in position. Later on, we will be having examples for that, but at the moment, we'll be computing for the analytic method for problem number 1. Okay, so again, since the description of the two vectors is that the angle measurement are measured from x, the corresponding components are computed using cosine for x and sine for y. Of course, cosine x gives you positive 1. You should verify this in your scientific calculators when you input cosine x. So for example, if you're going to illustrate that in your calculator, so for example, if we compute for cosine of wait, as you can see here, if we compute for the cosine of 0, wherein 0 is expressed expressed in degrees, that is why the symbol here is cosine d, meaning cosine degrees, where the value is equal to 0. Cosine 0 is equal to 1. So that means here cosine 0 is equal to 1. Cosine 0 is 1 times 50 gives you 50. Whereas cosine 0 gives you 0, you multiply that 50, that would give you 0. So let's verify that. So as you can see, in this illustration, sine of 0, where 0 is expressed in degrees, sine degrees of 0 gives you 0. Now again, since on the second vector you have cosine 0 is 1 times 82 gives you 82. Sine 0 is 0, multiply that with 82 gives you 0. Now adding the components vertically according to x with x, y with y, you have 82 plus 50, you have 132. And the y component is 0. Employing the solution to right triangles using Pythagorean to compute for the resultant vector. Let's try to see the computation. This is the computation. This is your Pythagorean theorem. Summation of the magnitude of the resultant vector is computed using square root of the sum of x square plus the sum of y square, or that would be the component of the resultant vector in x plus the square of the component of the resultant vector in y. That is 132 square, and 0 square gives you 132 as the magnitude of the resultant vector. For the direction, of course, r sub y, which is also your summation of y, is 0, and the summation of x is 132 degrees. 132. You have 0 over 132 gives you 0. Inverse tangent of that gives you 0 degrees towards the east. Now going back, graphically, the resultant vector is this one, the red arrow or the red vector, 132 degrees using the scale. This is about 132, just a little above 125 in the drawing. Okay, so let's have problem number 2. Okay, so this time, these two vectors are directed in direct opposite or direct opposition, one in the east direction and the other one on the west direction. So if we're going to see again the description of these two vectors, simply the difference between this problem and problem number one is that the orientation of the two vectors is one is directed towards the right and the other one is directed towards the left, but both of the direction is measured from x. So the 0-degree angle is measured from x, the 180-degree angle is also measured from x. Therefore, when if we're going to compute for the components of each, we will be employing cosine to compute for the component in x, and we'll be employing sine to compute for the components in y. And again, cosine 0 is 1, multiply that with 10 gives you 10. Cosine 180 degrees gives you negative 1. You multiply that with 6, that would give you negative 6. If you're going to verify that with using the scientific calculator, you have cosine. You have cosine. Wait. Cosine 180 degrees. 180 cosine. There. So notice that the result is negative 1. Cosine of 180 degrees is negative 1. So this is negative 1. You multiply that with 6. That gives you negative 6. Now, as for the y component, since both of the two angles was measured from x, we will be employing sine as the solution to compute for the y components. So again, sine 0 is 0. Multiply that with 10, that gives you 0. Sine 180 degrees gives you also 0. Multiply that with 6, that gives you 0. Let's verify that. 180 degrees sine. So that gives you 0. Therefore, you multiply that with 6. Here, this gives you 0. And again, to compute for the resultant, the components, we get the sum according to column. 10 minus 6 gives you 4. 0 plus 0 gives you 0. Now, if we're going to graph this, this would be, if we're going to draw this head to tail, or from the origin, this would be drawing the vectors from the origin. So as you can see here, the blue vector is your first vector, the green vector is your second vector. This is 10 meters east and 6 meters west for the green vector. So this is your first vector, the blue vector. The green vector is your second vector. The resultant vector is simply the difference between the magnitudes of these two vectors, since both of them are directly opposite. So you have 10 minus 6 gives you 4. Analytically, this is done using the component method as shown here in this module. Okay, so let's have example number 3. A car travels 4 kilometers north, 3 kilometers east, as we have shown in the graphical representation for problem number 3. These two vectors are actually drawn perpendicular to each other if we're going to draw them from the origin. There. The resultant vector is represented by the red arrow. If you're going to use parallelogram method for this one, the projections of each of the given vectors points towards the direction of the intersection of the projections. The resultant vector points towards that direction, as specified in the parallelogram method. Okay, so how did we compute now for the value of the magnitude of the resultant vector? Try to notice in our computation that since the 90-degree angle for the north and the 0-degree angle for the east are also measured from x, as shown here, the first vector 4 kilometers 90 degrees north, on the positive y-axis the angle is measured from x. The angle 0 degrees is measured also from x. Therefore, we will be using or employing cosine to compute for x and sine for y. Now notice, since the first vector is directed north, that means that you will be having cosine 90 degrees for computing for the x component. This would result into 0 since cosine 90 is 0. Multiply that with 4 gives you 0. Let's verify that. This would be 90, then cosine. 90, then cosine. There. Okay, so you have cosine 90 degrees, that gives you 0. Cosine 90 degrees gives you 0. Multiply that with 4, that gives you 0. Whereas if you compute for the sine of 90, that gives you 1. You multiply it with 4, gives you 4. So let's verify that. We have 90 and sine. There. So you have sine 90 degrees gives you 1. So this is 1 times 4 gives you 4. Now, since we already established the values, cosine 0 is 1 times 3 gives you 3. Sine 0 is 0 times 3 gives you 0. You add the components accordingly, according to columns. You have 0 plus 3 gives you 3. You have 4 plus 0 gives you 4. What is left now is to compute for the magnitude of the resultant vector. How did we come up with 5? Let's see the computation. So this is the computation. Again, we employ the Pythagorean theorem in order to compute for the magnitude of the resultant vector. So you have 3 square plus 4 square. 3 square is of course 9. 4 square is 16. 16 plus 9 gives you 25. Square root of 25 gives you 5. So that is the magnitude. As for the direction, we employ inverse tangent or arc tangent. You have summation of y over summation of x, or r sub y over r sub x. Of course, r sub y is 4 divided by 3. 4 divided by 3 gives you whatever value that would be. You compute for inverse tangent, that should give you 53.13 degrees. So let's verify using the scientific calculator. Okay, so you have 4 divided by 3. This value we compute for the inverse tangent. So this is one, the inverse tangent. So as you can see in the result, you have 53.13 degrees. Then the direction is north of east. So question, why is it that the direction is north of east? Now remember, in our discussion of the concept, whenever we employ the arctangent function summation of y summation of x, we always expect that the resulting angle is an angle measured from x. So if we go back to the computation of our components, the resulting components yields positive. Both of them are positive, so positive x and positive y. Therefore, the location of the resultant vector should be in the first quadrant as shown in the graphical method. It's in the first quadrant. This is your component in x, this is your component in y. Both of them are positive, as you can see in the diagram. Now, why is it that the compass direction for the resultant vector is north of east? It is because the angle should be measured from x whenever we employ the arctangent function. So therefore, the angle 53.13 degrees is measured from your positive x going towards this direction. This is your 53.13 degree angle. Okay, so next, let's have problem number 4. Okay, so problem number 4, we have 3 vectors. We have vector ABC, 2.6 kilometers, 4 kilometers, 3.10 kilometers. These are the corresponding directions: 90 degrees north, 0 degrees east, 45 degrees north of east. Now, as for the description of these 3 vectors, of course, vector A is directed north on the positive y. The angle 90 degree is measured from x. Vector B is 0 degrees. It is directed towards the east. The angle 0 degrees, of course, is measured from x. And finally, the third vector, 3.1 kilometers, 45 degrees north of east, is located on the first quadrant. The 45-degree angle is measured from x. Let's try to graph this set of vectors. Let's try to graph them using the drawing them from the origin. Okay, so this is your first vector, drawn north. The second vector, the green vector, is drawn east. And the third vector is the purple vector is drawn north of east, 45 degrees north of east. The 45-degree angle is this one, as measured from x. Now, the resultant vector is the red vector or the red arrow. So, how did we come up with 7.83 kilometers, 37.73 degrees north of east? Mathematically or analytically, this is done as presented here. So, based on the description, each of these three angle measurement was measured from x. Therefore, we will be employing cosine to compute for each of the components for x, and we will be employing sine in order to compute for each of the components in y. Now again, cosine 90 degrees would be 0 multiplied with 2.6, that gives you 0. Cosine 0 is 1, multiply that with 4, gives you 4. Cosine 45 degree, we should verify this using our calculators. Again, I am encouraging everybody to verify also the computation using your own calculators and using your own computations. Okay, so let's compute for the value 2.19. How did we come up with 2.19? Let's compute first for 45 degrees. 45 degrees cosine. So this is the result for cosine 45 degrees. That this value is multiplied with 3.1. So multiplied with 3.1 gives you 2.19 rounded off to the second decimal place. Okay, so that's how we come up with the value 2.19. Now, as for the y components, you have sine 90 degrees. Sine 90 degrees is 1. Multiply this with 2.6 gives you 2.6. Sine 0 is gives you 0. Multiply with 4 gives you 0. Sine 45 is also the same as the value for cosine 45. This is about 0.707, just like as the value of cosine 45 degrees. Let's verify that. We have 45 sine. So that is about 0.707. The same value for cosine. Multiply this again with 3.1 should yield the same value 2.19. Okay, now since we are done with the computation for the components, the next step again is to get the sum of the corresponding components according to axis. So 0 plus 4 plus 2.19 gives you 6.19. 2.6 plus 0 plus 2.19 gives you 4.79. Take note that both of these two components are positive. Therefore, we expect the resultant vector should be located on the first quadrant, just as shown here in the graphical method. The resultant vector, the red arrow, is located on the first quadrant. Okay, so how did we come up with 7.83 and 37.73 degrees? By this time, I am assuming that you already know the corresponding steps. After you have done doing the components, you employ Pythagorean theorem and inverse tangent. So let's see the computation. Okay, so this is the computation for problem number 4. You have 6.19 for x, you have 4.79 for y. And of course, what you're going to do here is you square the value for 6.19, you square the value of 4.79, you add them up, and you get the square root. You should be getting 7.83 kilometers. Okay, so let's do that in our calculators. Okay, so first you have 6.19 square This is your square. So that's the result. We should add this the with 4.79. This is squared. Okay, let me repeat that. So plus 4.79 squared. Wait, was 4.79 squared. Okay, so let me repeat. I'm having problem with my mouse. So 4.79 squared. Yeah. Okay, so you have square root of 6.19 plus square of 4.79. We should get the square root of this 22.9441. So square root of 22.9441. We should be able to get the um, okay. So let me repeat that. Okay, so this would be 22.9441, and we get the square root. Okay, so let me clear the screen first. Okay, so this is 22.9441 and square root. Okay, so let me repeat the steps. This is actually 6.19 square. So you have 38.3168. Uh, okay, so again, the square of 6.19 is 38.3161. Take note of that. I'll be clearing up the screen. And next is 4.79. We'll be squaring this one. So the result is 22.9441. I'll be clearing up again the screen. Okay, so the next step is to add the values of the squares. So this means you will be having um, 38.3161 plus 22.9441. Now remember the sum. The sum is 61.2602. Okay, so the next step is to get the square root of this value. So, the square root of this value, you simply click on the square root. The result should be 7.82 if you round that off to the second decimal place. That gives you 7.83 kilometers. Okay, so next is to verify the 37.73 degree north of east angle. Okay, so again, let's clear up the screen. You have 4.79 divided by 6.19. This will result to this value, and we should get the reverse tangent or inverse tangent of this value. Okay, so again, 4.79 divided by 6.19, it inverse tangent. So the result is 37.73 degrees. And again, north of east, north of east is located on the first quadrant. Since the result for 6.19 and 4.79, both of these two yield positive sense of the direction, positive 6.9, positive 4.79. Therefore, the resultant vector is expected to be located on the first quadrant, as we see here graphically. Okay, so let's proceed with another problem. Let's try to have let's have try to have this problem. This is problem number 12. I have skipped a few problems. I'll be giving some of those problems to you as an exercise, but that would be later on. Okay, so let's have this as a final example. Problem number 12. You compute for the x and y components of each of the following vectors. Vector A, 12 meters 37 degrees east of north. Vector B is 15 meters 40 degrees south of east. And what is being asked here is we are asked to find the magnitude and direction of A plus B, A minus B, and B minus A. Okay, so first let's try to draw the corresponding vectors. Okay, so problem number 12. Okay, so this is problem number 12. Let's try to draw. Of course, we are only given two vectors. One is, let's try to draw first the two vectors from the origin. Let's try to have this first as 1 is to 10-hour scale. Okay, so as you can see here, okay, so as you can see here, the two vectors, one is on the first quadrant and the other one is on the fourth quadrant. The blue or the first vector or the blue vector is located east of north, 37 degrees. So this is your 37 degrees. Your vector B, your green vector, is 40 degrees south of east. This is your 40 degrees. And that would yield the resultant vector as 18.71 degrees south of east. The vector arrows drawn here is a bit small. If you're let me zoom this up for you. So we cannot actually see because of the limitations of the graphical method. But if you're going to do this manually using your own drawings, you should be able to compute the. Try to notice that the vector arrow is very close to the x-axis because of the resulting angle is almost 0.18 degrees. Okay, so but the point here is if we're going to compute for each of these, letter A, letter B, letter C, we have no problem in computing for letter A because it is already computed here. This computation is actually your letter A, vector A plus vector B. Now, just take note of the signs of the components. These are the vector A is actually an angle measured from Y, whereas whereas what we have done in the previous examples is that we are given examples all of which the angles are measured from X. So the difference in the computation is that you will be reversing the computation for sine and cosine since the angle was measured from Y instead of X. So remember in our previous examples, whenever we employ the computation of the components in X using cosine, if the angle is measured from X. Now this time, our vector A, 37 degrees, is measured from the y-axis. Therefore, we will be employing the sine function to compute for the x component. So you have sine 37, you multiply that with 12, you are expected to get 7.22. Now, the reverse, of course, is that once you have computed for the x component using sine, you will be using cosine instead for the computation for y. Since again the idea is since the angle measurement for 37 degrees is the angle measured from y. Okay, so correspondingly, you should verify this using your own scientific calculators. Now, as for the computation for the y component of b, take note that vector b is actually located on the fourth quadrant, here the green vector, wherein the x component is actually positive. The x component is positive, and the y component, the x component is positive, the y component is negative. So that means you have a negative y and you have a positive x. Now, of course, the next step is to get the sum. 7.22 plus 11.49 gives you 18.71. And next is 9.58 over negative 9.64. That gives you negative 0.06. Now, of course, negative 0.006 is almost zero. That is why if we are going to compute for the magnitude of the resultant vector using the Pythagorean theorem, it is almost that the resultant vector is almost as equal in length as your summation of x. Okay, so let's try to do letter B. So letter B is A minus B. So what we're going to do is to look for or reverse the direction of our original vector B into its corresponding negative vector. So we expect that since the direction of the positive sense of the vector is south of east, we expect this in reverse. This would be north of west. So we'll do this in reverse by getting the negative vector. So as we can see here that the direction was reversed, it becomes north of west. Correspondingly, this changes the direction of the signs of the corresponding components. Now take note, the value of the magnitude of each component is the same as before. The only difference when you reverse the direction of your negative vector, what happens now is that the signs of the components would also reverse in direction. So originally, the positive sense of the vector b is positive 11.49. We reverse it in the opposite direction. This becomes negative. Now, for the y component, this is originally negative 9.64. Now, we get the negative sense of the vector. This becomes positive. If we're going to draw this graphically, reversing the direction of vector b, okay, so again the direction of vector b reverses the direction of your components. Let's try to draw again this from the origin. Try to take note that the direction of the resultant vector changes as we change the direction of the one of the vectors. So originally this set of vectors, the blue, the red, and the green, is the positive sense of the sum a plus b. But this time, since we reverse the direction of vector b, so we'll expect that the we will be yielding a different value for the resultant vector. So if we combine this using parallelogram method, we should be able to yield this vector, red vector arrow. So how much is the value of that vector? Based on our computation, that is 19.69, 77.47 degrees north of west. Let's see the computation. So this is your computation for the magnitude and the direction. Okay, so let me take note another point. Take note that the result for the sum of x is negative and the sum of y is positive. So we expect that the location of the resultant vector would be on what quadrant? It should be on the second quadrant, negative x and positive y. Now take note of the computation. The computation goes that we simply make use of the absolute value of all the given components, whether they are negative or positive. We substitute it in our computation in its positive sense. So our 4.27 value, since it is negative in our computation, although it's negative, we'll be computing it in its positive sense. The same goes with our inverse tangent. Our computation for 4.27 was negative, but if you're going to input it in our formula, you should be input it in its positive sense, in its absolute value. So positive 4.27. Okay, so let's try to answer the last letter, B minus A. So let's bring back first the vector B, and let's reverse the direction of vector A. Okay, so originally our vector A was east of north. If we're going to bring that back, east of north. If we reverse the direction, we have negative vector A. This becomes west of south. And try to take note, since the location of the 37-degree angle or the vector A is on the first quadrant, the corresponding components are both positive. Reversing the direction in its negative sense reverses also the signs assigned to each of the component. So this becomes negative, this becomes negative. Now try to take note that what happens to our vector is that this changes the value. It reverses the sign of the two vectors. 4.27 becomes positive, and 19.22 becomes negative. So since this is the value for r sub x is positive and the value for y is negative, we expect that the location of the resultant vector is on what quadrant? It should be on the fourth quadrant. So graphically, let's try to do this graphically. Let's make the okay. So let's make the negative sense of the direction for vector A, and bring back the positive sense of vector B. Okay, so let's again try to draw this from the origin. So try to take note the new set of vectors. This is your first set of vectors, blue, red, and green for A plus B. This is your resultant vector. This is your A plus B. Now this set, blue, red, and green, is your A minus B. This is your resultant vector for A minus B. And finally, for B minus A, this is your B. This is your B. This is your negative A. This would result into B minus A for the red resultant vector. And as expected, the location of the red vector for B minus A is located on the fourth quadrant, positive x, negative y. Okay, so let's try again the computation. So you have 19.69 meters, 77.47 degrees south of east. South of east is located on the fourth quadrant. Okay, so as part of your exercise, just like what I have presented to you for the graphical method, I expect that you will be doing the exercises, problems number 7, number 8, number 9, and number 10. But this time, using the analytic method. Okay, so this will be the end for the discussion of vectors. I expect that you will be submitting the exercises on April 18.